In the real world, truth is fragile. Eyewitnesses are unreliable, physical evidence decays, and human memory fades. But in mathematics, truth is immortal. It doesn't rely on interpretation, it relies on absolute certainty. It starts with a proposition. Think of a proposition as an educated guess, a statement that seems entirely true, but currently lacks the rigorous verification needed to trust it completely. The ultimate goal is to elevate that untested proposition into a theorem. A theorem is a statement that has been proven to be true and remains true regardless of the observer. To bridge the gap from proposition to theorem, you have to build a proof. A proof is the sequence of strict logical arguments that leaves zero room for doubt. Achieving mathematical truth requires navigating a strict logical obstacle course. And because every problem is built differently, mathematicians have developed specific methods to attack them. The first tool you reach for is the direct proof. It is the most straightforward method, operating exactly like driving from point A to point B on a single, clear highway. The mechanics are simple. You assume your starting hypothesis is true. Then you use a sequence of established logical deductions to walk forward until you show that the conclusion must be true. For example, we can prove that if an integer is odd, multiplying it by itself will always result in another odd number. By assuming the first number is odd, we follow a single arrow of algebra straight to the final answer. Direct proof works when there is a clear, unbroken chain of logic. But the moment the highway gets obstructed or the road branches out, this method stops working. That brings us to our first escalation, dealing with a problem where a straight line simply cannot be drawn. We handle this using proof by cases. This is a method of exhaustive verification, where you identify every possible scenario and prove the statement for each one individually until the entire field of possibilities is covered. Take this equation, n squared plus n. We must prove that for any whole number n, the answer is always even. Because n could be any integer, we prove it in two separate realities. We prove it assuming n is odd and assuming n is even. Both branching paths lead to an even result. By accounting for every possible scenario, the final conclusion is established as fact. But what happens when you face a proposition where there are too many cases to check and the direct path forward is completely blocked? You go backwards. This is proof by contradiction. It works by testing an alibi. You assume the suspect is guilty and then show how that assumption creates an impossible paradox with known evidence, thereby proving the original assumption was false. A famous challenge is proving the square root of 2 is irrational, impossible to write cleanly as a simple fraction. Mathematicians test a logical trap, assuming it is rational, but as they follow the algebra, the fundamental rules of division break down entirely. By proving that the opposite of your statement is a logical impossibility, your original statement is verified by default. Then we hit the final obstacle, attempting to prove a statement that contains an infinite number of possible cases. Checking every case manually would never end, so we use mathematical induction. This works identically to tipping over a perfectly spaced, endless line of dominoes. You only need to verify two steps. First, prove that the logic works for the very first item in the sequence. Second, prove that if any one step works, the step immediately following it is also guaranteed to work. Mathematicians rely on this to lock in complex formulas, like proving the precise sum of every positive integer stretching out to infinity. Induction removes the need to check every number manually. It establishes a recursive logic that applies to the entire infinite set at once. So what happens to a mathematical idea once it survives this rigorous gauntlet? It is finalized as a theorem. This is the endpoint of a proven proposition. The process often involves building blocks. You might construct a lemma, a smaller theorem that serves as a necessary stepping stone to complete the larger proof. Once the main theorem is established, corollaries often follow. These are secondary results that become self-evident the moment the primary proof is completed. These proving techniques are the framework human beings use to cut through noise and doubt to establish absolute certainty. When you're trying to win an argument, which of these logical pathways do you find yourself using most? Do you rely on direct logic or on exhaustive cases, or finding a contradiction? Please let us know in the comments.